All right, so for this first problem, we need to find the vertex, axis of symmetry, x-intercepts, y-intercept, domain, and range. So we know that first of all, our y-intercept is the c value. Okay, so our y-intercept here is 1. So I'm going to put that point on our graph. Now, next, I'm going to find the axis of symmetry. And that's going to help me find my vertex. So we're going to use the formula x equals negative b over 2a. So in this case, we have x equals negative times a negative 4, so that's going to be a 4 over 2 times 2. So we get 4 over 4, which gives us 1. Now that is our axis of symmetry. So I'm going to put this dotted line in at x equals 1. So we know that everything is going to be reflecting over this line. This is our middle of our parabola. We also know that our vertex is going to be on this line because that's the very middle of our parabola. That's the max or the min. It's that folding point. So to do that, to find the vertex, I'm going to take this x value and plug it into our equation. So I'm going to plug in a 1 wherever my x is. So I have 2 times 1 squared minus 4 times 1 plus 1. So I'm going to do the 1 squared first. So that'll give me 1 times 2 is 2 minus 4 plus 1. So now I have 2 plus 1 is 3 minus 4. So I'm going to get negative 1. So that means that my vertex is 1, negative 1. All right, now I also know that this y-intercept can be reflected on the other side of our axis of symmetry. So we were 1 unit away from the axis of symmetry, so to get the other point, I'm going to move 1 unit away and plot that point on that same line. All right, and now remember that I always want you to have 5 points on your table to graph these. So I'm just going to sketch out a quick table down here. So we have our vertex of 1, negative 1. We have our y-intercept of 0, 1. We have the reflected point of 2, 1. So now I'm just going to pick a random number that looks like it's in the generally the same area as our parabola. So I'm going to choose 3. So I'm going to plug in 3 into my equation wherever I see an x. Minus 4 times 3 plus 1. All right, so I have 3 squared is 9 times 2 is 18. Negative 4 times 3 is negative 12 plus 1. So 18 minus 12 will give me 6 plus 1 will give me 7. So that means I will get a point of 3, 7. So I'm going to look 3, 7 will be right here. So I'll plot my point, and I see that's 2 units away from the axis of symmetry. So I'm going to do 2 units away on the opposite side, which will give me another coordinate of negative 1, 7. So there are my 5 points. I have enough to sketch in my parabola now. So next we're going to talk about our x-intercepts. And those are going to be written as a coordinate with the y coordinate of 0 because we're staying on the x-axis. So I'm going to estimate that we crossed at about 0.5 and 1.5. So those would be my 2 x-intercepts. And then lastly, we have the domain and range. So our domain here is all real numbers because we can plug in any x value and get a y value. Our range is going to depend on our vertex here. Now we see that we have our y value of our vertex is at negative 1. Now from that point and above, that's where all of our y values are in our parabola. We have nothing below that. So we're going to say for our range that y is greater than or equal to -1. So this is always going to play off of our value that we get for our y coordinate, y part of our coordinate in our vertex. All right, and that's how you would graph these first problems. Check the completed answer key that I post on Google Classroom for the worked out answers for the second problem. So next we're going to talk about factoring. Now the first thing I want to do is I want to see if there's anything I can factor out of all three of these terms. So I can factor out a 4 and a p from each of these terms. That would leave me with 10p squared plus 17p plus 6. So now I see that my 10p squared plus 17p plus 6 is something that I can continue to factor even further. So I'm going to do that. Now, if you remember, we've talked about the process. You guys call it like the X. All right, so our a times c and then our b term. So a times c will be 60. Our b is 17. So we're looking for two numbers that multiply to 60 and add up to 17. So that's going to be 12 and 5. Now next to those, I'm going to put my variable of p. So what we're going to do is to break this down, we're going to have two sets of parentheses. We have our 10p squared and our 6 already in there, and then we're going to throw in these two factors, so plus 12p and 5p. Now our next step is to factor out the greatest common factor out of each set of parentheses. So with this first one, I'm going to factor out a 2p, and that leaves us with 5p plus 6. And then the second one, I can't factor anything else out. So I'm going to just factor out a 1, and that would leave us with the 5p plus 6. All right, these two sets of parentheses, again, should be the same. These are going to go in a set of parentheses together. So I have 2p plus 1 times 5p plus 6. Now remember, we still have this 4p, so that's just going to go out front. All right, and that's our final answer for that problem. All right, you're going to use the same kind of process that you started with here for this problem right there. All right, so you're looking for two numbers that multiply to 90 and add up to 47. Those are going to be your factors that go in these parts of the X there. All right, with this problem for number 5, we're just going to do greatest common factor. So I see that both 4 and 20 are divisible by 4. So I'm going to factor out a -4 because that first term is negative. So -4 can be divided out, and then we can also factor out 3 n's. So that leaves me with just 1 n minus 5. Now we have a -5 here because we started as a positive 20. We factored out a negative, so that will leave us with the -5 there. So we're changing the sign. All right, with this last one, I'm just going to show you the first little bit. We want to look for something that we can factor out of all three terms, and we can factor out an x. That leaves us with 6x squared minus 43x plus 72. All right, so you're going to go back and use the same process you did for number 3. Now again, you can check the completed answer key that I'll post that will have the completed worked out problems for these. All right, so next we're going to complete the square. So I'm going to do one of these problems, and then again, I'll have you check the completed answer key for the worked out solutions for the other part. So the first thing we want to do is we want to move this 78 over. So I'm going to subtract 78 from both sides. That leaves me with n squared minus 16n equals -80. And now I find my new c value. So to do that, I take my b, at -16, divided by 2, which will give me -8. And then I'm going to square that. So it's going to give me 64. All right, and I'm going to add that to both sides of my equation. So I have n squared minus 16n plus 64 equals -80 plus 64. All right, so I can rewrite this now as n squared minus 16n plus 64 equals negative 16. Now this left side, we want to factor. And I see that we're looking for two numbers that multiply to 64 and add to negative 16. Well, that's going to be n minus 8 and n minus 8. So I can rewrite that as n minus 8 squared, all right? Because that negative 8 plus negative 8 will give us the negative 16, and negative 8 times negative 8 equals 64. All right, so now we're going to solve. So I'm going to take the square root of both sides to cancel out that squared. So I have n minus 8 equals plus or minus the square root of negative 16. All right, now I'm just going to move this 8 over, and then we're going to clean up this right side here. So I'm going to add 8 to both sides. So I have n equals 8 plus or minus the square root of negative 16. Now remember, if we have a negative under that square root, that's telling me that we have an imaginary number. So I'm going to break this down as far as I can. I have negative 1, and then I'm also going to have my 16. Now I know that square root of 16 is 4, square root of negative 1 is I. So I have 8 plus or minus 4i. And you can break this out and write 8 plus 4i and 8 minus 4i, or you can just leave it like this. All right, both will give you the same answer. I'm happy with either way you write that. All right, so this would be the same process you would use for number 8, and you will get an imaginary number as part of your answer there as well. All right, so now we're going to take a look at solving an equation by factoring. So the first thing we need to do is factor. And in order to do that, we have to move everything over to one side. So I'm going to take a look at number 10 here, and I'm going to add that 4 to both sides so that we're equal to 0. So now I'm going to factor this left side. We're going to use this process again, the a times c, which is 12, our b is 7. So we're looking for two numbers that add up to 7 and multiply to 12. And I'm just setting up my parentheses over here. Now, how this problem is different from the other factoring problems we just did above is because this is equal to 0, so that means we're solving for the x values. Before we were just factoring and we stopped there. Here we're going to factor and then set each set of parentheses equal to 0 and solve for an x value. All right, so my two numbers that are going to multiply to 12, add up to 7, are 3 and 4. And I'm going to put my x next to those, and I'm going to plug them into my parentheses. All right, next step, we're going to factor out the greatest common factor from each set of parentheses. So this first one I can factor out of 3x, leaving me with x plus 1. Second set of parentheses, I can factor out a 4, leaving me with x plus 1. All right, again, we want these parentheses to match. That's a good sign. And then our other set is 3x plus 4. These are still equal to 0. So now I'm going to break this into two separate equations. And I'm going to set them equal to 0 and solve. So for this first one, I'm going to subtract 4 over, then divide by 3. So x will equal negative 4 thirds, and you're okay to leave it as a fraction. And then the next one, I'm going to subtract 1 over, so x equals negative 1. All right, so those are your two solutions for this problem. All right, so now we're going to work on some operations with imaginary numbers. So I'm going to work through a couple of these with you, and then again, you can check the completed answers for the final worked out solutions for all of these. Number 11, I know that we're multiplying because there's no symbol in between the two sets of parentheses. So we're going to use like our FOIL method. So first will give me negative 7. Outside will give me 21i. Inside will give me negative 8i. And last will give me 24i squared. Now, we're going to simplify this as best we can. I see that the 21i and negative 8i are like terms, so I can combine those together. So this will leave me with 13i. Now remember that I squared is equal to negative 1. So for this next part, we have 24 times negative 1 because it's multiplied with I squared. So that's going to give us a negative 24. We still have our -7. So we can now combine these two terms together. So I have my -24 minus 7, so it's going to give me -31, and then I'm going to carry down my plus 13i. And that is going to be my answer for this problem. Now number 14 is going to be very similar to this, except it's written, the beginning is written a little differently. So just remember that when we have this squared on the outside, that means we're doing 8 minus 5i times 8 minus 5i. All right, you're going to do the same process. All right, this next one, we have the minus in the middle, so that means we're combining like terms, we're subtracting here. So what I'm going to do is I'm going to change the signs of all the numbers after the minus and then just turn that into a plus. So what I did was I was already taking the subtraction into account here. So now I can just combine like terms and not worry about remembering to do the minus part. So I have 1 and a -7, so it's going to give me -6. And I have -3i and -8i, so that's going to give me -11i. Now remember that this is not I squared in this spot because we're not multiplying I times I. We're just combining like terms here. Number 13 is going to be very similar, except you are not changing any signs because we have that plus in the middle. All right, so now we are going to look at division. Remember that to solve these division problems, we need to multiply by the complex conjugate, and we look at the denominator for that. So we're switching the sign of the denominator, so the sign out front of the imaginary number in the denominator, and we're multiplying. So I'm going to multiply both the numerator and denominator by 10i, right, because we started with a -10i. Switch that sign. All right, so in the numerator, I'm going to distribute, multiply like that. So I have 10i minus 100i squared. All right, now remember, we're going to have to do a lot of simplifying in these problems. We have -100 times -1. That's going to give us 100. So I'm going to write this in the order that we usually see these complex numbers in. And I'm going to write that 100 before my 10i. So I have 100 plus 10i, and that's going to be my numerator. And then we're going to look at the denominator here, and we're going to multiply here. So we have -100i squared. All right, and that's going to give us -100 times -1, which will give us a positive 100. All right, and now last thing we can do is we're going to reduce our fraction if we can. And we can in this case. We can divide everything through by 10. So what that will leave me with is 10 plus I over 10. And you can put that 1 out front of the I if you want, but you don't need to. All right, now this last one is a little different. I'm going to show you the process for this one as well. But it's because we have two numbers in the denominator. Now when we have that, we're going to just switch the sign out front of that imaginary number. So I'm going to multiply through by 2 minus 3i. And it's going to be the same process. All right, but we're going to have to FOIL on both the numerator and the denominator. So I have -8. Then my outside gives me plus 12i. Oops. All right, inside will give me minus 14i. And last will give me 21i squared. All right, so I'm going to combine my like terms here. I get -2i. I still have my -8 over here, but this 21 is 21 times -1. So we're going to get a -21. We're going to combine that with that -8 to get -29 minus 2i. So that's going to be the numerator of my fraction. And now we're going to do the same thing for the denominator. Okay, so we have first is 4, outside is -6i, inside is positive 6i, and last is -9i squared. All right, these are going to cancel out. So we're left with 4, and then we have -9 times -1, which will give us a positive 9. So we have 4 plus 9, which will give us 13, and that's our denominator. So this is our final answer here because we cannot reduce anything. So that will be it. All right, and lastly, we're going to talk about vertex form. So we are given our equation in our y= form. So the first thing that we can determine is our direction of opening and our y-intercept. So remember, our y-intercept is that c value, so in this case is -3. Our direction of opening is going to be down, all right, because our a term is negative. So if our a is positive, we're opening up. If our a is negative, we're opening down. And in this case, we see we have that -2 there. All right, next thing I want to do is get my axis of symmetry. Same formula as before, x equals -b over 2a. So this is also going to give me my h value, which is going to be the x part of my vertex. So I have -b, so -8 over 2 times our a is -2. So I have -8 over -4, which will reduce to 2. All right, so that's my h value. And that's also the axis of symmetry, so x equals 2. So I can draw in my dotted line here at x equals 2. And that will be like my folding point of my parabola. Now to get the rest of our vertex, I'm going to take that 2 value and plug it in to my equation wherever I see an x. So I have -2 times 2 squared plus 8 times 2 minus 3. All right, now make sure you do the 2 squared first and then multiply that with the -2. So I have 4 times -2 will give me -8 plus 16 minus 3. All right, so this is going to leave me with 16 minus 8 is 8, minus 3 is 5. So that is the y of our vertex, or our k value. So h equals 2, k equals 5. And remember that our equation for vertex form is y equals a x minus h squared plus k. So we're switching the sign out front of our h, and our k just stays the same. So our vertex form here is y equals -2 x minus 2 squared plus 5. All right, so now let's plot our vertex. So we have 2, 5. We have a y-intercept of -3. All right, we can find the reflected point over here at 4, -3. And we're going to just draw our parabola in. And we see that it's opening down, so that's a good sign. And there's all the information that we need.